So let's see. Hi, everybody. Thanks for talking with me in conversation for the Collegeville workshop on developer productivity. Today, we're going to talk about issues in developer productivity, especially issues that you notice in academic environments. And here we have the authors of two white papers submitted to the workshop. And they'll be glad to tell you about their perspectives. I'm going to ask each interviewee to introduce yourself, a little bit about your background and why you're interested in this. Teresa, would you like to start?
Sure. I'm Teresa Windus. I'm a professor in the Department of Chemistry at Iowa State University. I'm also an associate with Ames Laboratory, a national lab in the United States for the Department of Energy. I'm interested in this because of my background is in computer science and in chemistry. We do develop a lot of software. And because I've got my foot in both of these communities, there's kind of a disparity that can happen between the national lab's expectations and what actually happens in academia. And so trying to train students and bring them up to the right expectations can be a challenge.
Thanks, Teresa. JP?
Yeah, I'm JP Lehr. I'm a PhD student at the Technical University in Darmstadt, Germany. I've interned at Lawrence Livermore Lab twice so far, so I'm a little bit aware of some of the lab work maybe, and also how it's different to the academic work that we do in Darmstadt, Germany in specifics. I'm working on tools, basically, or mainly tools for performance analysis and program analysis, and also do teaching and supervise bachelor and master theses, which is interesting if you want to get students do interesting work during their thesis in a software that you are developing in academia. So getting people productive in a very short amount of time for their thesis is something that I'm very interested in, and where developer productivity comes into play a lot, I think.
Thank you. Tomislav?
Hi, I'm a postdoctoral researcher at TU Darmstadt also, but in another group, in mathematical modeling and analysis group. So I landed there after studying mechanical engineering, so I'm somewhere in the direction of applied mathematics. And I'm basically developing numerical methods for multi-phase flow simulations. And that's important because these methods, I mean, in this context, because these methods, they do not have a completely rigorous mathematical background. So when you devise software for these kinds of methods, you have to do a lot of testing. And that's kind of my motivation for this meeting and for doing this kind of work, is to how to make it possible in academia, where it's difficult for many reasons that we will discuss, to test scientific software and make sure that when somebody contributes to it, that nothing goes wrong.
Thank you. So already in your introductions, you started to bring in some of the challenges that you see in developer productivity. Can you elaborate a little bit more about what you really mean by, what is the scope that you're talking about in terms of developer productivity, and what are some of the elements of the academic settings that you believe make this particularly challenging in contrast to industry or government settings? Teresa, would you like to comment first?
Yeah, I can start, but please interrupt if anyone else has thoughts as well. I think oftentimes we think about quality, reusability, sustainability when we're thinking about productivity. And oftentimes in academic settings, we're trying to get something done fairly quickly on a shoestring budget, and we're trying to get publications, which are the main sort of metric in our field. And so we don't often think about whether the software is going to be reused for any given purpose. So you might be thinking, oh, I'm just going to quickly write something up and then it'll just be mine. But oftentimes what we see is that those kind of softwares, what you might call a prototype, actually becomes the real software that gets used by the group. And it really hasn't necessarily had its interface well thought out, its ease of use by others, those sorts of things. Now there are some changes happening in my community that are helping to educate our community as a whole on just how important great software engineering techniques are to be able to help us to produce faster, code faster, as well as make it higher quality.
Thanks,
Yeah,
Teresa.
I think that's this having some prototype made up and then more by accident having this evolve into something that is actually used by a group, or you actually build the project on something that was never meant to be used as a foundation work. That is, I think, one of the challenges. And right into that, we just discovered that one of our prototypes that is now also part of a larger tool chain, and so it's getting used with production codes. The analysis that this tool performs now went up from, let's say, 5 to 10 minutes that is easily doable into about 13 hours because of just larger data set sizes, right? And so now it's pretty much unusable anymore because it's also part of an iterative process and yada, yada, yada. So, but changing it, so we have a clear idea of why it's behaving like that, but changing it and improving it would mean changing the overall underlying data structure. Now, again, this came out as part of a bachelor thesis, which is short time. You don't want to rewrite your whole code base in that part, right? So that's sort of, I guess, it's a challenge in a sense that you see this problem, yet you don't have necessarily the time or the power, the manpower to fix it in the given amount of time you have.
Right.
So this prototype to actual production software, all the steps in between that you would probably usually carry out seem to be missing in academia, at least for many projects.
Maybe I could also add that I think even at the front end, we're missing the design aspect, right? We don't normally ask students to think about design at all. And so I think that's a big challenge.
Yeah. So what are some elements that you've already been finding are helping to address these productivity issues? I know that your teams are really quite on the forefront of embracing technologies that are really helping quite a bit.
I mean, if I may say a few words on this,
Sure.
basically, I have a bit of a kind of a different perspective because I'm working with OpenFOAM, which is relatively large scale software, like hundreds of thousands of lines of source code. And it's actually using some of the design patterns that you usually find in professional software. So I think we are kind of in the middle in this situation because the software itself was developed with the purpose of being closed source. It ended up being open source. So it has this like industrial aspect, or let's say professional software engineering aspect. But the thing is, when you start to work with something like this, it's basically, at the time when I started, there was basically no documentation. And being confronted with a huge code base that has tons of different patterns and in C++ was really not easy. And I see the same situation even now with like more documentation being brought into this software. I see the same situation happening to people that start using it today. And why? I think that we have many disciplines that end up being connected to computational engineering that don't teach software design. So you have like mechanical engineering, we have people in the group from mathematics. I mean, people are coupling it to magnetohydrodynamics, to molecular dynamics. So chemists are also kind of playing with it. I don't know. And all of these people, they're strong in their background, but when it comes to like really architecture of large scale software, I think that's not something that's being taught, let's say, in mechanical engineering at all. And that's kind of a problem for us. Yeah.
Indeed. So have you been finding particular strategies that are beginning to help your communities address some of these difficulties?
I
Whoever would
mean,
like to start first. Yeah, go ahead.
oh, okay. Well, what we figured out in the group, at least, I mean, in the community, I can't speak for the community, but at least for our research group, we try to do it like this. So the postdocs are basically something that they mimic software architects in the software industry. So you can't just go to a master student or a PhD student and just assign him some development in open form, because this is not going to end up well. So you basically have to prepare the class hierarchy and the library and everything, and then just say, okay, here in this class, in this member function, you need to program your algorithm. And this is kind of like the way I think that is semi-manageable, say it like this. It takes a lot of time to prepare this work, but it makes it then possible for the person, for the young person starting with this, to focus on the numerics, on the, let's say, algorithmic work. And then by discussion and corrections, they can learn why we chose this design and stuff like that. So that's kind of one way. I don't know.
Do you actually do like peer review sort of things during the student work, or is that something that is then done afterwards, or is it part of your, I don't know, like bi-weekly meetings or so?
Well, we do it. So I mean that's the whole. I mean, at least I try to do this all the time. I would say there's a 50% of the colleagues are doing it all the time, basically, with students, because we just, as I said, we realized if you don't prescribe this, the let's say the class hierarchy is always about classes with C++ and object orientation. If you don't prescribe this design, they will write things that cannot be then integrated. So we have to check.
Yeah, I know we've added peer review as well into our workflow process, and that helps. It really does help to educate those who are just starting out. So that is a key part. I agree.
Yeah, I was mainly asking because for the projects that I'm mainly involved with, we started using a very structured Git branch and merge workflow as well, using pull requests or merge requests and doing peer reviews. And also now that we see that some of the students are getting more and more into specific parts, for example, with the Clang LVM toolchain, now they actually do peer review also the code that I check in. So which is also fun and also helps me, you know, think twice maybe about a certain design or approach. And I think this is also very valuable in a sense that it just improves the overall architecture and the overall quality of the code. So not only being the reviewer and all the pull requests and my code is perfect, right? Because that doesn't make sense. But also learning from students and discussing things, even now in full lockdown with everybody working from home using GitLab and all the infrastructure that is available. I think that's very valuable.
Indeed.
Yeah,
So
I think what you're
in addition to peer review, are there other practices that you're finding useful within your groups to help address these challenges?
So usually we have, when we start with a larger feature, we have some discussions before that. What's actually necessary to achieve it? What are the requirements? What are the goals? What is a use case also? Like, for what can we use it for? What do we need to use it? We usually just jot that down in a Slack channel then after the discussion, such that we have some written down thing that everybody agrees on, sort of. And then, you know, like, people are recreating the task or the issues in the repository, so people can then work on a specific issue or a specific feature and also reference that description.
Yeah, I know in our group we do things like that, gathering requirements, all of those nice software engineering aspects that help. One of the things that we've also tried to do is talk through alternatives to the design, because this really does help to strengthen everyone's skills in building a better design. Because anyone who's written even a simple piece of code know that you can do it in multiple different ways, especially in C++. And so just having those conversations actually helps the whole team. But it takes a while for new people to get into the flow of it. It's a time thing. And I think we have to just realize it's another aspect of the education of anyone who wants to be in computational sciences or computer science.
I think that's actually a very, sorry if I jump right at that point, but I think this is a very valuable statement, because what I realized is that some of the students, so I'm a computer scientist by training, and so all my students are basically computer scientists, but they are not necessarily prepared to work in a structured software engineering like way on something larger than a couple of hundred lines of code, which is also because in our curriculum, mainly we focus on very small parts, understanding the nitty-gritty details of a specific C++ atomic, I don't know what, right? But it's not, oh sure, we use this workflow to actually contribute to the software. So I think having people also, or adding such workflows in teaching would be something valuable. And we actually want to try this in the next semesters, where we have people develop plugins for LLVM where you can easily have some of the Git magic being part of the actual teaching. But we don't have any experience yet how well that
Yeah, training is indeed important and often not part of the base curricula. Tomislav, do you have comments?
Yeah, I mean, so far we basically kind of use this transfer of knowledge directly by working with students on assignments. And I mean, it depends also, I mean, depends also on the motivation of the student. Sometimes if the task is really directed towards physics, more towards physics and less towards some numerical atomic, I would also can call it like an atomic something, algorithm or something, then some people are just not motivated enough, so to say, to also attack this side of the design. So I think it should be, I think, a part of the standard curriculum in every computational engineering course. That's definitely something that needs to change soon.
Yeah, I would just add that I think like in the science areas or engineering, right, we already have a lot of classes that are required just to learn our own technical base information. So it can be really hard. And so I know that like with my group and others do this as well in my field, is we have sort of a series of tasks that maybe have been done before, but that actually help to train the student in thinking about more complex software as they go along. So for 6 months, they might not actually do any software development that's going to contribute to the real code, but it helps them to learn how to do the programming in the science base that we're in. And so a lot of these are also in our Molecular Sciences Software Institute. That's an NSF-funded program to try to train the general community. But it takes time. But I think there is this software evolution happening now where people are realizing that this is needed to actually have productive students and have excellent code.
So Teresa, you mentioned that the multi-community is developing resources that could be accessible to anyone who's interested. Is that correct? Through the
Yeah, that's right. And I can make those, oh, sorry, Lois. I can make those available in a link but it's really, we do have some initial design kind of things, using Python, using Git, doing workflow. We don't have one on, at least I don't think so yet, on software review, but that's something that's in the pipeline. So, and they're really geared for late undergrads, early graduate student kind of thing, but we've had postdocs take it who have not had that kind of training.
Thank you. JP and Tomislav, do you have any pointers towards resources that might be of interest to the community generally?
In terms of software design?
Yeah, or any of these elements of productivity that relate to your work.
Well, basically, I mean, definitely look at design patterns. So object-oriented design patterns. That's something that the book of 4, I mean, that needs to be read multiple times. Sometimes, I would say. I would start with this. And also to take, there's a book, I don't remember the author's name anymore, but it's like growing object-oriented code by testing, something like this, like test-driven development. That's something that's easy, let's say an easy thing to do, to apply to your workflow daily, that makes it possible to define nice interfaces. Because you start writing the tests, and then you, so to say, put your user hat on, as the author says, and then you are basically forced to kind of write a nice interface, because you are kind of defining the interface for yourself. So you don't want functions that have 20 arguments and things like this. So when you start writing the test application, you do it, and then you, once you write the test application, then you go to the library. So it's kind of like a trick to make APIs better. So I would say test-driven development and design patterns. Yeah, this would be a good thing to do.
JP, any comments on this?
Yeah, I think my main part of this would actually be that students are, or people are aware of the tool chains that they can use, that they can actually use, or that they can actually work as a team in a workflow, that they know how to use Git, that they know how proper peer reviewing works, how I don't know, static linters can help, like lang tidy, find bugs very early in the development process, and then also follow the Boy Scout rule. So just whenever you develop something in the code and there's an issue, a small issue, you can fix it and commit, and just having this continued working on quality of code. But for the start, it's just being able to work in this sort of workflow and know the tools that you can use would just, yeah, greatly help and be more productive, in the sense that because you know all this, you can focus on writing the code that you actually should write, or making the design, because you don't need to learn Git first and then learn how to use the GitLab web front end, and then how to use Slack and how to use this and that. So I guess that's a fair point.
Well,
I
this
think
is
that actually brings up, oh, I'm sorry, could I just make one more quick point?
Yep.
I think this brings up another issue of productivity, which is all of the time that we spend with build systems and and trying to get those to work right, and you know, and the testing, you know, as was brought up, that those, you know, you spend a lot of time working on trying to get your code to link. And so, you know, the build system can be really challenging and is really difficult for most of the students, especially, but debugging is just really hard as well, right? So all of those things that go into making the code actually run, and hopefully run for your users, right, is really, you spend a lot of time there. So CMake is great in many ways, but in other ways, it's still very difficult to use. We've developed some of our own tools on top of it to try to help us make that a little bit easier, but it's still challenging.
Thank you. So these are all really important elements of work. I'm sure people listening to this interview will appreciate your drawing their attention to some resources and ways of thinking that can help. We'll need to wrap up now, although I could continue talking about this for the next 2 hours. It's so interesting. But since we've been asked to keep our interview fairly brief, I'll just ask each of you if you have any final thoughts that you'd like to conclude with. Teresa?
I think we've talked about some of the big pieces, especially in academia. It can be challenging when, you know, your team is pulled in multiple different directions here to try to make this all work together. So I think it really does take a community to try to help build sort of a sociology behind having really good practices, that and realizing it just takes time to get everybody up to speed. Hopefully by the time they finish their graduate education or their postdoc, they're ready for their next steps. They're ready to train the next generation. And so I think that's just really important.
Thank you. Tomislav?
I definitely agree with this. And also for students, I think it would be good to try and like involve yourself in open source projects. I think this is something that's quite good that I've personally missed. I mean, I've worked with OpenFOAM, but it's not the only thing that you can do. I mean, there are so many codes out there, and I think it's good to involve yourself in different open source projects, so to say, because then this will show you like different ways different communities work together. That would be also a
Good
nice
point.
thing to do.
JP, any comments?
Yeah, I'm so happy somebody said build systems, because there's not a single week where there's no issue with one of the build systems we use. I think that for specifically in academia, where you rely heavily on students and student assistants or theses to actually put software out, put ideas out, that incorporating these workflows, incorporating how an open source community would work together in a team to develop software, incorporating those techniques and workflows into the actual teaching, thus the standard curriculum courses would actually help the students become better and better with these ways of working, with these ways of contributing, with these ways of learning from each other through, for example, peer review processes. And so that is something that we certainly want to incorporate in our teaching more and more and more, so that when students hopefully do theses with us, they can start with the actual work more easily, and be more productive on the actual coding, and not deal with the other details.
Very important. Well, thank you to all of you. This has been a really interesting discussion.
Likewise, thank you.
Thank you.
Thank you.